Good morning. Today we're going to finish up the rest of section 5.7. Yesterday we started talking about how we can use the idea of congruent triangles to then make determination as to other parts of those triangles. So in my little diagram that I have here with two triangles, you can see that we have some given information within the pictures. You can see as an example that angle A in one triangle equals angle D in the other. You can see that side AB in one triangle equals side DF in a second triangle. And you can see that side AC equals side DE. And when you put those together, an angle, a side, and notice that the angle is included between, we can then make the determination using SAS that the triangles are congruent. So with this given information, we could then say that the two triangles, I'll call this one ABC, and this one DFE, would be congruent to each other using SAS, side angle side. Again, that's fine. We've been doing that now for a while. But now the extension of that is once we know these triangles are congruent to each other, then any other corresponding parts also have to be equal. So as a result of determining the triangles are congruent, we can then say any other angles, as an example, angle C and angle E have to be equal to each other because those are both the angles across from the side with one tick mark, so they're corresponding, have to be equal to each other. We can say that angle B and angle F have to be equal to each other because those are the angles across from the side with two tick marks. And the remaining side in one triangle, BC, it has to be equal to the remaining side in the other triangle, FE. Those are the sides across from the angle with one tick mark, so those are all equal because they're corresponding parts. Okay? So that was what we started talking about yesterday, and today we're just going to look at 4 examples, 2 that I made up, and then 2 that are from your assignments. So if you're actually watching this video like I asked you to, you can get 2 of your assignment problems done as well. The first one is just one that I made up. It's very similar to a problem we did a few weeks ago, but it's this diagram with 3 pieces of given information, and then I'm asking you to prove that angle J and angle L are equal to each other. Okay? So feel free to pause the video if you want to put this one into your notebook. Feel free to pause the video. Otherwise, I'm just going to get going by writing down the given information. So K is the midpoint of IM. So that's given to us. Angle I equals angle M equals 90 degrees. That's given to us. And I'm going to attach a box in each of those corners to remind us that those are 90-degree angles. And then finally, the third, KJ equals LK. So that's given to us. So KJ, this one, is equal to LK, that one. All right, so from the given information, you can see then that we either have a side of each of the triangles being equal, we have an angle being equal, but the side that we're given could possibly also be a hypotenuse depending on how the problem works. So we're not sure if we should consider those to be sides or a hypotenuse. Okay? All right, so what else would we need? Well, as an example, since K is the midpoint of IM, that means the distance from K to I and the distance from K to M must be equal using the definition of midpoint. And so I'd be able to tell that K to I, K to M are equal. Now that looks like it gives us another side, which of course it does, but possibly it could also be the leg of a right triangle. And so what you're seeing in the margin is possibly SAS or HL. Okay, what we'd like to say next is that the triangles are congruent. So triangle IJK and triangle MLK are going to be congruent, but should it be SAS, HL, or maybe it doesn't matter? Could it be either one? Well, it can't be SAS, so let me put that down, even though this isn't going to work. SAS is not going to work because the A angle is not included between the sides that we know. So it can't be SAS. It must instead then be HL. So we know the triangles are congruent, and again, that's normally where we had been stopping, but now all we're saying is once we know those are congruent, any other corresponding parts, like angle J and angle L, have to be equal, and we can use our abbreviation CPCTC, corresponding parts of congruent triangles are congruent. And we're done. Okay? Like always, feel free to pause the video and finish off the rest of that proof if you're choosing to put it into your assignment. All right? Feel free to pause. Okay? On my next problem, my next example, I'm going to use number 8 out of the book. So this is one of your assignment problems. But instead of just writing a plan as they describe it in the directions, I'm just going to do it as a full-fledged 2-column proof. Again, this is your book problem number 8 from section 5.7. Okay? So the given information is going to be shown in the diagram, and I'm just going to put it into our proof like we always would. So I'm going to start with side AB equals side CD. That's given to us, right? Then I'm going to say that angle A is equal to angle D. That's given to us. And finally, the last thing that's given to us are these 2 upper angles at E, but instead of using all of the letters, I'm just going to choose to call that one angle number 3 and this one number 4, so I don't have to use all the darn letters. And again, you guys can always feel free to do that as long as you show me that on your picture, and that would be given. So right off the bat, do we have enough information to say that the 2 triangles, which I'm going to highlight for you, so this triangle, ABE, and this triangle, CDE, do we have enough information to say that those are congruent? Well, let's take a look in the margin. AB equals CD, that's a side of each. Angle A and angle D, that's an angle in each. Angle 3 and angle 4, another angle of each. So is that one of our shortcuts? Yes. So therefore we can say the 2 triangles are congruent, A, B, E, and triangle D, C, E are going to be congruent to each other using 2 A's and an S. 2 angles and a side. Please notice, just to be picky, the side is not included between the angles, so we should be using AAS, not ASA. I know it's just a little picky thing, but there we go. Okay? Now, once we know the triangles are congruent, any other that we don't already know, any other corresponding parts, and what we're concerned with here are BE and CE, then have to be equal to each other. We also have other things. We have other sides, we have another angle that's equal, but this is the one we're really concerned with. BE and CE are equal to each other, and let me put 2 tick marks on those 2 sides. All right? So those 2 sides are equal because they're corresponding parts of the red and blue triangles. But that's not what we're trying to prove. We're trying to prove that angle 1 and angle 2 are equal. And how do you do that? And you might notice I've already written it down, so you know I'm on my last step already. Well, the idea is to then focus on the triangle, the single triangle in the middle. And if these 2 sides are equal, that is then an isosceles triangle. And we had a theorem from 2 weeks ago that said the base angles of an isosceles triangle are equal. So to get there, it's the base angles theorem. Again, if we have an isosceles triangle, the two base angles, the angles opposite the two equal sides are equal. And we've proven what we were asked to do in this problem. Okay, again, like always, feel free to pause the video if you need to finish that one up. Okay, I'm going to move on to my next example, which is the book problem number 13 from section 5.7. Once again, they give us a picture with a lot of information on it. Lots and lots of information on it. And we're supposed to try and prove that the distance from F to L and the distance from H to N are the same, are equal. Okay. Alrighty. Now I'm going to choose to do that by first adding a couple of angles to help myself out a little bit. I'm going to add a 1 and a 2 for those two angles right there. I'm going to add a 3 and a 4 to those two angles right there. All right, that's just going to help me out so I don't have to use letters. And then my plan is to start by proving this upper left triangle is congruent to this upper right triangle. I'm going to prove those two are congruent, right? And it doesn't take much. Let me do it relatively quickly. I can say that FG is equal to HG. That's given to us by the tick marks. While I'm at it, JG is going to be equal to KG. That's given to us in the picture. And what that gives us right off the bat is two sides for each of those triangles. Two sides. Okay? The reason I put the number 1 and the number 2 in there is I'm going to then say angle 1 equals angle 2. That's not given to us. You don't see tick marks there that show us that. But because we have intersecting lines, we know those are equal because those are vertical angles. And of course, what that gives us then is an A. And I need you to notice that the A angle is included between the two sides. So therefore, the two triangles, the red, I'll call FJG, and the triangle on the other side, HKG, are going to be congruent to each other using side angle side. And once I've proven the red and the blue are congruent, the important statement that I need to use for this problem is that side FJ and side HK are equal to each other. And those are equal because they are corresponding parts. So CPCTC, corresponding parts of congruent triangles are congruent. Now I'm going to draw a broken line across because I'm kind of separating now, Then I'm going to do something almost identical with these two triangles. So now I'm going to pick this one that I'll outline in purple, this lower left triangle, and let me select a different color so it shows up here. Let me try this yellow for this lower right triangle. And what I'm going to do is prove those two, the purple and yellow, are congruent to each other. So I'm going to start with JM and KM are equal to each other. Again, back to all the tick marks that they showed us in the picture. LM equals NM. That's given to us with all the information with the tick marks. And again, what they give us right off the bat are two sides. Okay, once again, because of the way the lines intersect, we can then say that angle 3 equals angle 4. Those are equal to each other because they are vertical angles, which gives us then, of course, an A. And just as we had in the upper two, the lower two triangles then have to be congruent. So JLM and KNM are going to be congruent to each other using SAS. And the reason I wanted to get to that is so that I could say, here's the important statement, J to L has to be equal to K to N, because those are corresponding parts. Again, I'm going to draw a little dashed line across just to kind of separate those two. And then I'm almost done, believe it or not. I'm going to choose a highlighter tool here. I wonder, maybe red will work out okay. Now what I'm going to do is take this result from the first half of the problem, this result from the second half of the problem, and I'm going to add the two equations together. So I'm going to add the left sides together. So add left Fj to left JL, and the right-hand sides together, HK added to KN. And of course, it's perfectly legal to add equal things to equal things. That's called addition property. And then to finish, we're one step left. All I have to do is think of these two together, Fj, the upper part, plus JL, the lower part, equals FL. HK, the upper part, plus KN, the lower part, is then going to be equal to HN. And I know it's been a long time, but that's small segment plus small segment equals big segment. And so our postulate from months and months and months ago would be segment addition. Add small plus small, that's equal to big. That's called the segment addition postulate. And that's what we were trying to prove. Okay, so you can tell it's kind of a long proof, but broken up, the first 5 steps and the second group of 5 steps pretty much parallel each other. So just kind of doing the same thing 2 times in a row, and then using the results from each. Okay, again, feel free to pause the video to take a better look at that, and then move on to the last example. All right, so here's my last example. Right, and this is kind of a tough one. But what we have is one triangle that's broken up into quite a few smaller pieces. And after all is said and done, what I'm trying to get to is showing that angle 1 and angle 2 are equal to each other. Okay? Alrighty. So how can we achieve that? How can we get that done? Well, like always, we start with the information that we're given. And so I start you off with AD equals CD. That's given to us. AD is this length, CD is that length. Put tick marks on your picture to help out. AB and CB are equal length. So putting tick marks on the picture, AB, CB are equal length. And please notice that even though some of the sides are shared, when you look at what you're given together, we're actually given information about the two, let's see, no, there it is. The two kind of smaller triangles off to the left side. So if you guys would focus on this triangle from A to B to D, and the triangle from C to B to D, if you guys would focus on those two, what we have in those two smaller triangles right now is we have two sides. We have two sides, right? So even though angles 1 and 2 are not part of those smaller triangles, we do have the ability to prove those two triangles are congruent. We just need one more step, and a relatively easy step. If we just say BD in the red equals BD in the blue, and of course anything is equal to itself using reflexive property, that of course gives us another side. Now what we have, you can see it in the margin, SSS. So therefore the two, and I better put a tick mark on there just to help out. Therefore we can show that the two smaller, red, A, B, D, and blue, C, B, D, are going to be congruent to each other using side, side, side. Now how does that help us? How does that get us anywhere? How does that get us anywhere? Well, now that I know the red and blue are equal, any other corresponding parts also have to be equal. And the two that I'm going to concern myself with are angle number 3 and angle number 4. Those are going to be the two that I concern myself with. So I'm going to try and sneak in a tick mark on those two angles. So try and sneak in a tick mark there and there. And then in my proof, I'm going to say angle 3 and angle 4 are equal. And they're equal, of course, because those are corresponding parts of the red and blue congruent triangles. Now, why is that such a big deal? Why is it a big deal to get to that? Because now what I'm going to do is I'm going to switch to two other triangles. Instead of looking at blue and red, I'm now going to ask you to look at the triangle from A to B to E, and the triangle from C to B to E. Okay? And if you look at those two triangles, what do we know about those two already? Let me choose a highlighter here. What we know, guys, is that from up above, we already know that CB in the purple equals AB in the yellow. We already know a side. We know that angle 3 and angle 4 are equal, so we know an angle in the purple and we know an angle in the yellow. So what we have right now is a side, hit the wrong button. We have a side and an angle in each triangle, right? From the picture, do we know anything else? And here's kind of the tough one to figure out or come up with. We know that the shared side between the two, BE in the yellow and BE in the purple, let me choose my highlighter again, BE in the yellow and BE in the purple have to be equal to each other. But of course, anything is always equal to itself using the reflexive property. And what that gives us is, again, choosing my pencil here, what that gives me then is another side. And if you look closely, the two sides and one angle that we know in the yellow and purple, the angle is included between. And if the angle is included between, then those two triangles have to be congruent. So the yellow, A, B, E, and the purple, C, B, E, have to be congruent to each other using SAS. And if the yellow and purple are congruent, then any corresponding parts, including angles number 1 and 2, have to be equal to each other, right? Because the triangles are congruent, right? Any other corresponding parts have to be equal. And so you can see that's what we were shooting for, right? Angle 1 and angle 2 being equal. So even though that isn't terrifically long, it's only 1, 2, 3, 4, 5, 6, 7, only 8 steps long. It's actually shorter than the previous problem. I think it's quite a bit harder. We had to start by proving the small red and blue triangles were congruent, then use a result from that, angle 3 and angle 4 are equal, to prove that the larger yellow and purple were going to be equal to each other. Congruent to each other. Okay? So that's it then for section 5.7. So use the second half of the hour then to work on the assignment. I'll be back tomorrow. We'll go over questions, turn this one in, and then move ourselves on. Okay? So hope you're having a good day, and we'll talk to you tomorrow. Bye.